from time to time, people get stuck, and it's an inconvenience. We want to get to a meeting, we want to go home or whatever. And yes, I get that some people are claustrophobic and don't like being in a tight space. But again, there's plenty of air. No one's going to hurt you. The elevator's not going to fall. Elevators can't free fall. There's so many safety devices to prevent that. And even if they did, like the cables were to break, which is nearly an impossibility, there's a separate device that's monitoring the speed of the elevator. And if it exceeds a certain speed, there are these big clamps that clamp onto the main guiding members of the elevator, and it comes to a stop. And those are tested with full load at full speed. So worst case scenario, that's what they're designed for. And over and above that. It isn't like the elevator has a capacity of 2,000 pounds, and if we put 2,200 pounds on it, it's going to break and fall. No, that's not the case. It might overload a motor or a sensor, but it's not going to break and fall. No way. It's nearly an impossibility. I don't know that I've heard of, maybe 2 or 3 elevators that have fallen over the years, but but we're talking about really rare catastrophic failures, like in a hydraulic system. You've heard here and there, but it's only been like I said, 2 or 3 that I've heard of in 40 years. So it's very, very rare.
Yeah, that's comforting for people to hear. How have they also evolved over the years, both elevators and escalators? You mentioned some of the wonderful ways that they have. What are some other ways that they've sort of evolved?
No, it's a good question. We'll start with elevators. In the old days, let's say 100 years ago, these engineers were designing things on paper, so they didn't have CAD-assisted, computer-assisted, computer-aided design to engineer things. So they would calculate how thick something needed to be in terms of steel, and they determine it, and they draw it all on paper and those old blueprints and all that sort of stuff, and build it. And I've visited elevators. I maintain elevators, and I've inspected elevators that are nearly 100 years old that are running fine. And certain aspects of it might need upgrading, the door operators or these components that get used quite a bit. But the core of the elevator itself is rock solid. It's built like a train. It's just this, these huge pieces of steel. So the evolution of elevators from there, as designs come into play, and some of these larger companies, Otis was taken over by United Technologies, which is a gargantuan company that does aerospace. So they incorporated some of the designs from aerospace, and things weren't made as thick and huge anymore. And it wasn't that it was being compromised. It's that it was adequate, but it just wasn't as huge and thick and heavy. So less material, and obviously with the aid of the advent of computers and that technology, solid state technology, now we're over the years they were introducing solid state circuit boards for certain aspects of the elevator, run the doors or whatever, and they incorporated more and more and more to motor control and more sophisticated positioning of the elevator within the elevator shaft. There's a system that I'm really familiar with these days. It has essentially a barcode on a strip of metal, a thin strip of metal that runs the entire length of the hoistway. So there's a camera basically that reads this barcode from bottom to top in the hoistway, and it records that information. So the elevator system knows where it is at all times within about 3/16 of an inch. You have to do this process where it's called a learn. There's a lot of systems, but I'm just talking in generalities where you're engaging the system and it's going to do a learn. It learns the hoistway. So now the elevator knows where it is at all times. And the change from that technology to 30, 40, 50 years ago, it's night and day, because there used to have to be physical switches inside the elevator shaft in order for the elevator to know where it was as it would travel up and down the hoistway. So there was a lot more materials on the elevator itself and a lot more relays and technology in the controllers themselves to be able to interact with it. And now the systems, like the one I described, which is, there's a lot of them out there, it might be 10 or 15 wires from the elevator controller. That's the main brain up in the elevator equipment room. 10 or 15 wires that go to the elevator, where in the old days, there'd be 40 or 50 wires and all these things to connect, and it's more complicated and sometimes harder to troubleshoot. You might have a wire that's broken or all these different devices, but with these newer systems, it's a lot more streamlined and a lot simpler. So there's just been, I'm just giving it overall, but over the years, there's been this the technology has been introduced to these systems, and it's really improved it. And, there's been some challenges along the way, obviously, with computer systems. There was a company that went all in, let's go all solid state, and it was a bit much. There was a lot of problems. These boards weren't as reliable, and it was just too much technology all at once. So some of the companies were smarter about introducing little pieces of it, little sections of the elevator, if you will, to the computerized part. Another part that's really interesting and I've seen evolve is with respect to the motor control. So that's the motor that's driving the elevator. They've come up with a technology that has, you spoke, I think it was your mother, about how rough the elevator ride was and when it came to a stop and so forth. But the technology is such that there's a secondary device mounted on the motor. It's a miniature generator or encoder or whatever you want to call it, but it's producing pulses that this computer is reading as it rotates. And the computer is programmed to know a specific acceleration curve, amount of acceleration and deceleration, so that it's coordinated and it's monitoring the pulses coming out of that encoder or tachometer. So the system knows to keep the elevator motor running at that predetermined curve, and it bases if it's going too fast or too slow, overloaded or light, based on the output of that little device I mentioned. So you really don't know. You can't feel the difference between a full elevator of 10 people or one person in the elevator because of this technology monitoring the speed of the motor on startup and slowdown. It can maintain this ideal acceleration and deceleration curve. So this is from, looking back 50 years to that technology, it's absolutely night and day and a game changer. The old elevators, the elevator is approaching the floor, maybe this is the kind of elevator your mother was riding, and it would give a signal to turn off the elevator, to stop it at the floor. And what would happen is it's going at a given speed, and it turns off. It says, okay, we're close to the floor, and the brake would grab the brake drum on the motor and stop the unit. Well, that's fine, and you set the tension of the brake and how much slide there is on the system, on the braking system when it's decelerating, based on an ideal amount of load. And that's going to change, obviously. So you set it up, let's say, for two people. It's coming in primo. It's level both directions. But then when it's empty and it's going up, the counterweight is heavier than the elevator. That ratio is heavier. So now it's harder to slow down because the counterweight, there's a greater imbalance. So it's not as accurate in both directions. Then again, if the elevator is loaded up with 8 people, whatever the capacity is, now the elevator is heavier than the counterweight, so it's going to be going a little bit slower. So the floor level accuracy is not really there. It's kind of arbitrary. It's just based on how that braking system is stopping the elevator, whereas the one I described, the high-tech one, the brake really comes into play after the elevator comes to a stop electrically, and it's holding the elevator at the floor versus stopping it on the brake. So it's a completely different set of technology and a different riding experience, really, and the maintenance experience. It's a lot easier to maintain these higher tech ones that level in a lot smoother versus the older ones that slide to a stop.
Big difference, yeah. And that is a terrific improvement for the rider overall, just the experience of the elevator. What are some of the things that you think distinguish you from others that might do similar work?
Good question. Like I mentioned, most of the consultants I know did have some time in the trade, although they didn't spend as many years hands-on. Most of them did not spend as many years hands-on doing the variety of repairs and experiences that I've had. I'm not, patting myself on the back or anything. I'm better than anyone else. It's just this hands-on experience. I think I have a lot more hands-on experience, and I was really lucky to work for some really good elevator companies with great bosses who kind of, it's like parents letting you, go ahead, go on, have fun, do what you want to do as long as you're responsible. My bosses were kind of the same way. Can you handle this repair job? Yeah, I think so. Yeah, let's go. I need this and this widget and this hoist and this tools, and we would do it, and things were great, and the boss would give me more leeway next time. So I've had some experiences with some pretty challenging situations, and it's kind of fun sometimes to go on an inspection and, there's a flood or a fire or some failure, and I'm there with the elevator company who maintains the building. I'm there on behalf of the insurance company who's going to be paying for that claim. And the elevator company say, oh, well, 1, 2, 3, 4, those are all broken, and we, you got to change them. And I go, well, you know what? 1 and 2 are broken, but not 3 and 4. Look, they're fine. They didn't get wet. They didn't get burned. They're fine. Well, yeah, I guess you're right. So there's a little bit of debating and arm twisting back and forth. But in reality, you want to fix the elevator to where it was before it was damaged. But it's just the hands-on experience. I know it. I've been there, done that. So it's really helpful, and I feel that I have a pretty good knowledge about that, and that having that hands-on experience really helps.
That's incredible. That's really, really fantastic for people to realize. What are some of the reasons that an elevator can malfunction?
Good question. There's a litany of things. There's so many sensors and so much going on for the elevator to run. The doors have to close. Not only they have to close mechanically, but there's an electrical signal associated with it. Then, the physicality of closing the doors. There's a door operator, and there's sensors on it. There's signals going to it to tell it to close. Once everything's closed, it's telling the system, okay, now we can start. Let's go when we run up or run down, whatever. So there's a lot of things happening. I call it a symphony of things that all have to go correctly. And in most cases they do. Like I said, they're pretty reliable. However, there's things that can damage it. Things that don't help are when people are kicking or pushing on the doors or hitting the buttons too hard or too often. Things wear out. Like, in your car, the brakes wear out and, widgets wear out. All kinds of things wear out. So, there's debris that gets in the system. A relay or a mechanism can only operate so many times. And, you don't think about how often a relay, for example, there's door close relay, door open relay. These are signals that need to happen. And these relays, they're designed for, 500,000 operations or something like that. Well, after 20 years, it's probably going to get 500,000 operations, and it's going to wear out. And then it's going to interrupt the way the system is supposed to flow. So, things like that. There's a lot of things. I can't say there's one thing that caused them to be unreliable, but there's a lot of things happening at once that need to be, that need to happen to be right.
Exactly right. We're just about wrapped up with this episode, but next week I think we can delve into talking about some of the safety devices that have been produced most recently, a great deal that you've already mentioned, but then we can slide into the work as an expert witness, which is something really fascinating that you do that I think we can definitely elaborate on the next episode. Our very special guest, Robert Cotton, will be with us next week. That is July 18th, also at 10 a.m. Eastern Time. So look for that. Robert, thanks so much for sharing this with us. Really fascinating work that you do, extraordinary work, and very important work that you do. And appreciate your stopping by the show today, and hope you enjoy the time with me as much as I have with you, Robert.
I did. Thank you so much. I really appreciate it. Really enjoyed it.
You're very, very welcome, and keep up the amazing work, of course, and more next week here on Close Up Radio. We really appreciate Robert's time.